tailored testing, or it is also called what? Computerized adaptive testing. So let's take a look at the basic theory of tailored testing. What is it? Okay, what is it? It is also called individualized testing. Okay, each examinee receives each examinee receives their own set of test items suitable for their ability level. That is to say, all test items administered are not too difficult and not too easy, just at the right level. Right? Now, let's take a look at the procedure, then I'll explain. Let's say, we have a lot of test items calibrated in terms of item difficulty. So let's, any student, let's start up with the medium difficulty item. Administer the item. If the answer is correct, then the next item is more difficult. You see, this is item difficulty. This is item 1, 2, 3, 4, item N, all right? So for the first item, is an item of medium item difficulty in the item bank. The item bank consists of a lot of test items on that particular subject matter. Okay, let's say, all those items are, all those items have been calibrated in terms of item difficulty, right? So this is an item of medium difficulty. A correct answer, the next one is what? The next one is more difficult, right? And then a correct answer, the next one is what? More difficult. Then an incorrect answer, the next one is easier. Okay, this is an easy item. Correct answer, more difficult items. The next item, more difficult. Correct, more difficult, more difficult. Incorrect, easier item. Incorrect, easier item. Correct, more difficult item. Incorrect, less difficult. Correct, and so on. And very soon we will see that the item item difficulties will be within this these bands here. Okay, within these bands here. Then we have reason to believe that the examinee's ability is within the range here. Okay, let's assume we could equate item difficulty with with examinee's ability. Let's say we could do that, right? So this is the mechanism of what we call the tailored testing. Okay? And then, of course, at the very beginning, back in the 70s, okay, this is the idea behind tailored testing. We are still using tailored testing, but more advanced level. Okay, now we call it CAT, right? Computerized adaptive testing. Okay, and of course, those of you who will be writing, say, GRE or writing other standardized tests, hoping to get into an Ivy League university, you are given the option to write a regular test like a 300 item test, or to write CAT. Okay, so how does this work? It's based upon this, but then of course it is it makes good use of the computing power. Okay, so it's the same thing here. Okay, same thing here. All right. Now, of course, this is one example. I could give you another one. Okay, I could give you another one example for another student. Another student maybe like this. Okay, this student. Oh, come on. Like this. Okay. Oh, too difficult. Too difficult. Then give the student easy answer. Then, oh, correct here. Okay, correct here, incorrect here, incorrect here, correct, incorrect, correct, incorrect, correct. All right, so that student's what? Ability level likely to be within what? Within the range here. Now, of course, here, you know that in what? Here we are using multiple choice items. And in multiple choice, there are guessing. But then, even with guessing, we will arrive at this sort of pattern. Okay, so here are two examples. One is a more capable examinee, another one is not so capable. In computerized adaptive testing, what it does is this here. Okay, they also begin with what? An item of medium difficulty here. Then let's say here, a correct response. Let me do this. A correct response here. Then what is the next item? Then the computer, let's say I have an item bank here. Full of test items. Let's say test item 1, test item 2, 3, 4, and so on. Test item K. Okay, full of test items and fully calibrated. So what the computer would do is after what here, a correct answer, the next item is more difficult, and incorrect answer, the next item is what should be easy. But then how to determine the next item? Well, let's say given this pattern of responses, the computer can calculate or estimate the examinee's ability, and then what? Here, find the best item for what? For an ability level as estimated here. So the best item, let's say this item is selected, and what? It is administered. Correct response, and the computer would take this response pattern and then estimate the examinee's ability, and then go back to the test item bank and select the next item that is the best. Okay, that is the best for this one ability estimate. Okay, all right, and the next one is correct here. Next one is correct here. Okay, look at the green. Then the computer have this set of responses, is that right? So then the computer will estimate the examinee's ability and then choose the best item, the remaining item, the best out of the remaining items for this subject. So it's always the next item is the best item for the current ability estimate. All right? So then of course the computer also calculate it's called what? SEM. What is SEM? Called the standard error of measurement. They calculate the error. Okay, when the error is less than or equal to 0.03. Never mind how to calculate that, because the mathematics are you won't be happy with it. Okay, it's crazy. Okay, crazy. Anyway, when the standard error of measurement is 0.03 or less, then stop. Stop. And the examiner's ability, that examiner's ability will be what? Will be calculated, and then what? The error associated with this estimate is only 0.03. Okay, for this examiner, and as a matter of fact, we could do that for all examinees. Another examiner may be like this, all right? We still go through the same process. Now, so therefore, different examinees receive a different set of test items, a different set of test items. But then, because what? Because the procedure stops at this 0.03 when the error is less than or equal to 0.03. So all what examinees will be measured with the same precision, even though they receive different different sets of test items. We could still arrive at a very accurate estimate of their ability. Now, see here, to do this here, we overcome guessing in multiple choice. All right? Well, you guess, but eventually your guess may be wrong or your guess may be right. But then what we calculate it, we take into consideration guessing. Okay? So when the error of measuring the examiner's ability drops to 0.03 or below, well, bingo, we stop. So every examiner taking computerized adaptive testing, they receive different set of test items. Each one has a different set of test items, and yet we could compare their abilities. Isn't that good? And we overcome guessing. And now you say, wow, how many items here should we administer before this? Now, let's say, we calculate the ability estimate using 100 test items. See, 100 test items. Okay, and then we arrive at an accuracy of ability estimate. Now, using CAT in general, we could achieve the same accuracy, okay, using 18 to 21 items. See, take a look at the economy of the testing procedure. All right, so it is fast, but of course here we need a computer terminal to do that, All right, so but then what? Nowadays with the computers are not expensive, right? We could afford to do all that, okay, to do this here. Now, CAT is now available for those students writing SAT in the United States and writing GRE graduate record exam if you want to get into graduate schools. Okay, this is available, an option you could choose. Okay, and it's very accurate, and also 100 test items in about as many minutes, or sometimes 60 minutes, okay? But here, 21 items, within 20 minutes, you're out of the test site, right? So this is at first, this is called tailored testing because it's mechanical testing procedure. We have to choose if it is correct, the next item is fixed, okay, and so on. Then with the power we had in computer, starting in the 80s, okay, we have CAT. But of course, CAT uses a lot of computer power, a lot. Okay? So it wasn't the theories they were all was settled back in the 80s. But then what in terms of practice, well, it had to wait until the computer has such power to do that, because what, to choose the best items here takes a lot of calculation, right? So lastly, Peter Child's PhD thesis was on this. just to let you know, and then the math is crazy. But then what? This is what ingenious, isn't it? The idea is ingenious. Everyone will have a different set of test items, and yet what we could compare their ability estimate. Thank you.